Data transfer is continuous, that is, there are no packets. Okay, packets are only in packet switch networks. So data transfer is continuous and happens at the physical level. No addressing is involved except during the setup phase. Since you have established a connection, now there is a dedicated path. You don't need an address. Okay, whatever you said is going to go through that particular path. So no addressing is required in circuit switch networks. Okay. Now this is an example of how these four can communicate to the four over there. Since it's a voice signal, so you can see that the bandwidth is from 0 to 4 kilohertz, because you know that voice occupies at max 4 kilohertz of bandwidth. Okay. And then you see here there is a kind of switch, after which there are multiplexers, then it reaches here, then there are again demultiplexers, and then it finally reaches the destination. So this one you see is from 0 to 8 kilohertz, while this one is 0 to 4 kilohertz. Why?
Because the line in the middle has
exactly.
two
It can
stations.
carry the data from two users at the same time, because you see here there is a multiplex. So when they multiplex, so they are multiplexing the data of two users. Each user is taking 4 kilohertz. So two users will take 8 kilohertz. So now you can see that they are communicating. So for example, this guy, his data comes like this, and it passes from here, and then if it's supposed to go to 5, it goes to 5, or if it is supposed to go to 6, it goes from here to 6. And this example describes exactly this. Okay. So telephone 1 is connected to 7, 2 is connected to 5, 3 to 8, and 4 to 6. Let's take an example of this one. 1 is connected to 7. How? This is 1. Okay, it goes like this, and from here it goes to telephone number 7. Right? And of course, if someone else wants to talk with someone else, then these connections, the switch will change. So the switch controls the connections. Okay. This is another example. Okay, this is a standard which is known as schema line. Its speed is 1.544 megabits per second. So these are the four devices that would like to communicate with the four devices over there. This is a switch, which is a 4x8 switch. What's the meaning of 4x8?
4 inputs.
4 inputs and
Eight
8 outputs. So you can see that these 4 are inputs, 1, 2, 3, and 4. And the 8 outputs, 1, 2, 3, 4. And this is 5th, 6th, 7th, and 8th output, right? And you can see that these four outputs are going straight to the other destination. But these 4 outputs are folding back.
Yes.
What?
Because they are out from the other stations, the other 4. This 4 are.
These 4 are to communicate with the other 4, right? But why these are folded back? If I don't have these, what's going to happen?
So
those cannot communicate with each other.
Exactly. When they are folding back, this is if he wants to communicate with him. So straight it will be through this switch. Alright? Yeah? So then it goes through this schema line, then it is demultiplexed, and then again you see there is another switch 4x8, same, just like here 4x8. And he's gonna make sure that it reaches the destination. Okay, this is another example of circuit switching. And this is describing this figure that we just saw. Okay. Now there are 3 phases, as I said. The actual communication in a circuit switch network requires 3 phases: connection setup, data transfer, and connection teardown. So these 3 you have to remember. In circuit switching, there are always 3 steps: setup, or connection setup, or just setup. Setup means that the transmitter sends a request. I want to transmit some data to you. Okay. If he is ready to accept, he will send an acknowledgement that okay, you can send. This is setup phase. Then there is a data transfer. Now once this is established, then there is a data transfer phase in which you transfer your actual data to the receiver. And once you finish transferring, then you have to close the connection so that somebody else can use that connection. efficiency. Circuit switch networks are not as efficient as the other two type of networks. Why? Because resources are allocated during the entire duration of the connection. As long as the connection is there, nobody else can use that connection. It is dedicated for those two guys. That's why it is inefficient. So even if you are not using it, even then the connection is there and it is being wasted. While in packet switching, what happens? That connection is being used by many users. These resources are unavailable to other connections until the connection is there. In a telephone network, people normally terminate the communication when they have finished their conversation. So telephone network is an example of an inefficient network in the sense that the connections are always there even if you are not talking to someone on that phone. Okay, delay. Although a circuit switch network normally has low efficiency, the delay is minimal. Of course, because nobody has to wait. Once you pick up the phone and dial a number, okay, it goes right away. So you don't have to wait. So there is no delay or minimum delay. During data transfer, the data are not delayed at each switch. The resources are allocated for the duration of the connection. Figure 8.6 shows the idea of delay in a circuit switch network when only two switches are present. This is an example that gives you an idea of what's the meaning of delay. Now you see here, this is user A or device A, and this is device B. So this guy wants to transfer data to this guy. Okay. On the way, on the path, there are two switches. So what's going to happen first? Before that, you see this is time. Okay. So this guy first he sends a request. You see this yellow line. It goes there, and when B receives it, and if he's ready to accept data, he sends an acknowledgement. Okay, I'm ready to connect. Okay. My question is that why this bar is like this?
Time will move on. Take time.
Yes.
Yeah, because he sent it until you will reply at the same time. But in recent take time, that's why it's.
Yeah, because this is time axis, right? So if it is straight like this, that means it is reaching there in zero time, which is not possible, right? So he's showing that it's going to take some. For example, let me give you an example for those who did not get the idea. Let's suppose he starts here at 1 p.m. right? By the time he reaches, 1 p.m. was here, right? If you see this level, 1 p.m. is over there. But it's not going to reach at 1 p.m. Maybe it will reach at, just an example, 1 p.m. Okay, it will take only milliseconds, but that's okay. So you see this is the delay. This time, that's why this line is not straight, it's a little bit down. Right? It's going to take time by the time it reaches there. And similarly here, when it starts here, let's suppose at 101 or 102, by the time it reaches here, some time is passed. So this is the time that is spent in setting up the connection. Right? Is that clear? It's important. You have to be able to read this diagram. So once they establish the connection, now this guy is going to send data. And you see now this is the data going and it reaches here. So once he finishes, there is a tear down and he closes the connection. Right? Now again, another simple question. These bars are small, while this bar is big. What? Anybody other than these two? Yeah.
Because that.
Yeah, because the amount of data is too much. Like for example, in the setup, you might be just sending 1,000 bits, but for data, you might be sending 1 million bits, right? So that's why it's going to take more time, and that's why this one takes less time, and this one also takes, because setup and tear down, you just need a small, simple control signal. Okay, so this is connect, this is data transfer, and this is distance, right? So this axis is time, and this is the distance that they are traveling. Okay. Now, before I go into that, let me solve a problem. because by the time I do that, you will forget. Let's solve this problem first before we go to further details. Problem 8.9. A path in a digital circuit switch network has a data rate of 1 megabit per second. Okay, let's first try to understand what he's asking. The exchange of 1000 bits is required for the setup and tear down phases. The distance between two parties is 5,000 kilometers. When the first time I gave this problem in the exam, students were asking, what is this parties?
2 parts. Each one is.
Yeah, two users, one is sender, one is
Receiver.
source or destination, whatever you call it. 2 users or 2 devices, parties means that. So the distance between parties is 5,000 kilometers. Answer the following questions. The propagation speed is this much. Okay, first let's try to understand what is given and what he's asking. Again, a path in a digital circuit switch. So first of all, when this type of problem comes in the exam, you have to see is it circuit switched, packet switched, or what it is. So this is a circuit switch. It has a data rate of 1 megabit per second. What is this 1 megabit per second? You can call it, this is the bandwidth or bit rate, right? Bandwidth, bandwidth has several meanings, or you can call it bit rate. Right? It is 1 megabits per second. The exchange of 1000 bits is required for the setup and tear down phases. What does it mean?
To control the amount of data.
Exactly. When you are sending a request, can I transfer data? So that will take 1000 bits for the setup as well as for tear down. Okay. The distance between two parties is 5,000. So this is the distance. Distance is 5,000 kilometers. Be careful with the units. Okay, this is kilometers. Answer the following questions if the speed is 2 exponent 8. So the speed is 2 into 10 to the power 8 meters per second. Okay. Now, is this statement clear? He didn't ask right now, but are these lines clear to you?
Yes.
Right? There are 2 users, one here, one here. He's given the distance. He gave you the speed. He told you how many bits he's transferred. Right? Now, part A. What is the total delay if 1000 bits of data are exchanged during the data transfer phase? Now remember, there are 3 phases. Okay, one is the setup, one is the data transfer, right? And the third one is tear down. Okay, what is he asking? Total delay. Okay. Total delay means how much will be the, how will you do that? You will say total delay is equal to the delay for, or the time required for setup, right? Plus time required for data transfer, right? Plus time required for tear down. Agreed? There will be 3 types of time.
Yeah.
No problems, right? Okay. Now the thing is that, you remember we talked about 2 types of delay, or 2 types of time. One is transmission time, and the other is propagation time, right? Okay. Let me remind you, propagation time is how much time 1 bit takes from this point to this point. 1 bit. That is called propagation time. And that is something that you have already studied in physics and other courses, which is distance divided by speed. Right? Distance divided by speed. That is propagation time. Then there is transmission time. What is the difference? That transmission time depends upon how big or how much is your data. If your data is this much, it will reach quickly. If the data is this much, it will take time, right? 1 kilobytes of file and 1 megabytes of file will take time. So that means you also need some other time, which is transmission time, right? And for transmission time, you would say size of your data divided by bandwidth or bit rate. Right? Clear? Okay. So this means that when I try to find these times, I have to calculate all these times. So first of all, I will take delay for setup. Right? This will be equal to propagation time for setup phase, right? Plus the transmission time, let's call it TR, transmission time for the setup phase, right? Agreed? Any problems here? So propagation time for the setup, how much will it be?
5,000 kilometer, 5 by 2, multiplied by 10 to the power 8.
Right. Now since this is in kilometers, so and this is in meters per second, so I have to multiply it by 10 to the power 3. Right? So this is the propagation time for the setup phase, right? Plus the transmission time for the setup phase. What is the formula for transmission time?
Message divided by
Message size divided by band. How much is the message size for setup phase?
1,000.
1000 bits is required for the setup and tear down phases, right? So I will say 1000 divided by bandwidth. How much is the bandwidth?
1 meg.
1 meg. 1 into 10 to the power 6, right?
The other two, the data transfer and tear down will take the same time because they have the same amount of bit.
Yes, we'll come to that. You are too fast. Yeah, but you are right, absolutely. So this is the setup time. But you see, remember in setup time what happens? Data start, the request for transfer starts from here, it reaches here, and then his reply goes from there and then it reaches here. So these are two. Right? So I have to multiply this by
2.
2. Agreed?
Okay, agree.
Another point is, you see this propagation time? Is it going to be different for tear down, data transfer and setup?
No.
Why? Because distance
Same.
is the same whether you talk about setup, data transfer or tear down. Speed is going to be the same whether you talk about setup, data transfer or tear down. Right? So that's why this is good. So I calculated here for only once, and then I can use it in all of them. I don't need to do it again. Okay, so now when you calculate this, how much it turns out to be? This is 2 multiplied by 5 into 10 to the power 3 plus 3, 6. Okay. 2 into 10 to the power 8 plus this one is going to be 10 to the power 3 and this 10 to the power 6. When it goes up, it becomes 10 to the power minus 6. Minus 6 plus 3 is
Minus 3.
right? Okay. So this is 5 by 2 is 2.5. Right? So it is 2 into 2.5 multiplied by 10 to the power, this goes up, minus 2 plus 10 to the power minus 3. Right? Now at this stage, if you like, you can use your calculator and calculate it. But if you are like me, who wants to do it by hand, then you can do it even by hand. This is also minus 2, this is minus 3. Let's make it also minus 3. So this becomes 0.25 into 10 to the power minus 3 plus 10 to the power minus 3. So 0.25 plus 1 becomes 1.25 into 2 becomes 2.5 milliseconds. Am I correct? Can you see in your calculator?
There is 2.
Yeah.
There is 2.
Yeah. There is 2.
But
I agree with
it's 2.5.
This is 0.25 and this is 1. This is 1 apple and these are quarter apple. So 1 apple and quarter apple becomes 1.25 apple. Multiplied by 2 becomes 2.5 apple, right? And 10 to the minus 3 is milliseconds. Right? So this is the time for the setup phase. Right? Is it clear? Any questions here? Right? It's straightforward, simple. Right?
Yes.
Okay. Now you will find out this time for data transfer phase. Okay. Everything is here, and let me see if how much you learned.
The same.
The same.
The same.
See,
No, I said.
when you take the decision so quickly, you make mistake. It's not going to be the same. There will be things which will be same, of course, but not everything.
Data transfer need more time,
Efficient transfer.
as we say. The figure.
Calculate it, and then I will answer your question. I will not say anything right. Yeah, find out this time for data transfer.
10 سنة جروب 1 جروب 1 10